Every message you send eventually becomes raw bits on a wire. So how does that happen? The answer lives in the two lowest layers of the network model. Layer 2 is the data link layer, and Layer 1 is the physical layer. Start at Layer 2, whose job is to organize bits into frames. A frame is a structured container for data on the local link. It wraps the payload with a header and a trailer. The header carries the source and destination MAC addresses. The trailer carries a checksum called the frame check sequence. That checksum lets the receiver detect if the frame was corrupted. A MAC address is a device's physical hardware address. It is 48 bits long, usually shown as 12 hexadecimal digits. The first half identifies the manufacturer, the second half the specific card. Because it is burned into the hardware, every MAC address is globally unique. Now imagine many devices sharing a single physical medium. If two of them transmit at the same instant, their signals collide. Media access control is the set of rules that governs who transmits when. On classic Ethernet, that method was called CSMA/CD. Modern switched networks avoid collisions by giving each device its own link. Once the frame is ready, it hands the bits down to the physical layer. The physical layer defines how those bits become real signals. On copper cable, bits travel as changing electrical voltages. On fiber optic cable, bits travel as pulses of light. On wireless, bits travel as modulated radio waves. The medium changes, but the bits it carries stay the same. Together, these two layers move data reliably across a single link. That is the data link and physical layers.